Hello everyone, I'm Mary Josephine, Assistant Professor, Department of Physics, Nirmala College for Women, Coimbatore. Through this video lesson, we are going to learn about optical fiber and its applications. Through this video lesson, we are going to learn about what are optical fiber, structure of an optical fiber, propagation of light through an optical fiber, advantages and applications of optical fiber. An optical fiber is a cylindrical waveguide made of transparent dielectric like glass or plastic, which guides light waves along its length by total internal reflection. A practical optical fiber is cylindrical in shape, which is in general made of three coaxial regions called core, cladding, and the buffer coating. Core is the innermost light-guiding cylindrical region. The diameter of the core is of the order of 8.5 micrometer to 62.5 micrometer. Cladding is the outer optical material that protects the core. The diameter of the cladding is the order of 125 micrometer. The refractive index of cladding is always lower than that of the core. Light launched into the core and striking the core to cladding interface at an angle greater than the critical angle will be reflected back into the core. Since the angle of incidence and reflection are equal, the light will continue to rebound and propagate through the fiber. The outermost region is called protective buffer coating. It is a plastic coating given to the cladding for extra protection. This coating is applied during the manufacturing process to provide physical and environmental protection for the fiber. Light propagates as an electromagnetic wave through an optical fiber. The light rays entering the fiber strike the core cladding interface at different angles. As the refractive index of the cladding is less than that of the core, majority of the rays undergo total internal reflection at the interface, and the angle of reflection is equal to angle of incidence in each case. Due to cylindrical symmetry in the fiber structure, the rays reflected from an interface on one side of the fiber axis will suffer total internal reflection at the interface and on the opposite side also. Thus, the rays travel forward through the fiber through a series of total internal reflection and emerge out from the exit end of the fiber. Since each reflection is a total internal reflection, there is no loss of light energy and the light confines itself within the core during the course of propagation. Because of the negligible loss during the total internal reflection, optical fiber can carry the light waves over very long distances. Thus, the optical fiber acts essentially as a waveguide, and it is often called a light guide or a light pipe. At the exit end of the fiber, the light is received by the photodetector. Total internal reflection at the fiber wall can occur, and the light propagates down the fiber only if the following two conditions are satisfied. The refractive index of the core material must be slightly greater than that of the cladding. At the core cladding interface, the angle of incidence between the rays and normal to the interface must be greater than the critical angle. Only those rays that are incident at the core cladding interface at angles greater than the critical angle will propagate through the fiber. Rays that are incident at smaller angles are refracted into the cladding and are lost. The diameter of an optical fiber is very small, and we cannot use bigger light sources for launching light beam into it. Light emitting diodes and laser diodes are the optical sources used in fiber optics. Optical fibers are made from silica, which is one of the most abundant materials on the earth. The overall cost of a fiber optic communication is lower than that of an equivalent cable communication system. The cross section of an optical fiber is about a few hundred microns. Hence, the fibers are less bulky and are quite flexible and strong. A wire communication link could accidentally short circuit high voltage lines and thereby creating a great damage. Such accidents cannot occur with fiber links since fibers are made of insulating materials. In optical fibers, information is carried by photons. Photons are electrically neutral and cannot be disturbed by high voltage field, lightning, etc. Therefore, fibers are immune to externally caused background noise generated through electromagnetic interference and radio frequency interference. The light waves propagating along the optical fiber are completely trapped within the fiber and cannot leak out. It reduces crosstalk, therefore transmission is more secure and private. Optical fibers have ability to carry large amount of information. The transmission loss per unit length of an optical fiber is about 4 decibel per kilobyte. Communication techniques can be used in local area network, which is a computer oriented communication system. LAN operates over short distances of about 1 to 2 km. In LAN, a number of computer terminals are interconnected over a common channel, allowing each computer to use data and programs from any other. An optical data bus offers a great reduction in cost and increases the information handling capacity. One of the most important applications of fiber optic communication is long haul communication. Long haul communication systems are used for long distances. Telephone cables connecting various countries comes under this category. Another important application of fiber optic cables are in the field of medicine. An endoscope is an optical instrument which facilitates visual inspection of internal organs of a human body. It is also called as fibroscope. Thank you. Happy learning.